All right, we'll continue the answers to the review guide with number 53. 53 is real straightforward. It says a standard six-sided die is rolled. What's the probability of rolling the number 4? There's one number 4 out of 6 possibilities. Number 54, a number cube die is rolled 440 times, and the results were recorded as followed. So right away I can tell that this is experimental probability. The fact is, in theory, we know that, say, a 4 should come up 1 out of 6 times. But then in practice, the results might be a little different. And so out of 440 times, 71 came up, or 1 came up 71 times, 2 came up 76 times, and so on. And so we want to know what's the experimental probability. In other words, what actually happened when, as far as rolling a 2 or a 3 goes. Well, probability is always successes over total outcomes. So the total is real obvious. There's 440 outcomes, and the question is, how many of those were successes? And success is a 2 or a 3. Remember, OR is code word for add in probability. There were 76 2s, and over here we can see 65 3s. So we have the successes on top, the total outcomes on the bottom. And so we'll simply, and it looks like our answer's in a decimal, so I won't bother with the fraction here. But let me add 76 and 65 together. Well, I will bother with the fraction. 141 over 440, and I'm just going to let my graphing calculator tell me that that is 32%. So the answer is A, experimentally. That might not be the theoretical probability of rolling a 2 or a 3, but it is what actually happened when we did the experiment. All right, 55. In a class of 30 students, 12 have green eyes. If 2 students are chosen at random, what is the expression that will calculate the probability that both of them have green eyes? Well, if we're going to do this, it's going to be choosing one of them and then choosing the next one. So the probability that the first student, so we've got the first student and we've got the second student. So first is green, and second is green. Well, the probability that the first student is green is 12 out of 30, which does simplify, but I'll leave it as 12 out of 30 for the moment. And then the second student, assuming the first student had green eyes, the second one, well, I only have 11 students with green eyes left, and there are only 29 students left because I already chose one that had green eyes. Now, if I was putting the student back and had the possibility of drawing them a second time, the exact same student, then I would leave it 12 out of 30. But since I'm probably not able to choose the same student twice, this is what we'll want. And it just asked for what the expression was, so I think I covered that right here without going and actually finding the answer. Okay, number 56. A bag contains 12 blue marbles, 6 red marbles, and 9 white. What are the odds of drawing a blue marble from the bag? Okay, so the whole point of this question is for you to understand that odds are different from probability. And we already said that odds were successes over total. Probability is success over total. Odds is also a ratio, but it's a ratio of number of ways to succeed over number of ways to fail. So it's successes over failures. So success defined here is drawing a blue marble. Well, there are 12 blue marbles, so there's my successes. My failures, on the other hand, and just for clarity, I'll do the failures in red, would be a non-blue marble. And if I look, there are 6 plus 9, there are 15 ways to fail. So my odds can be written as a fraction. I should probably simplify it. Let's see, I think both of these have a 3, so 4 over 5. Or I can say 4 to 5 or 4 to, with the word to, 5. But the odds are 4 to 5. Probability would be different because probability would have the not just the failures down here, but the total number of outcomes. All right, 57. A spinner has 5 equal portions, colored orange, red, blue, yellow, and green. What are the odds of spinning a blue, yellow, and green? Well, this question is actually a little bit vague, but I think my assumption here is that they're saying what are the odds, what are the odds against spinning a blue, a yellow, and a green? Well, I think this question is a little bit oddly worded. First of all, I think parts and portions is in duplicate. I think we can eliminate one of those words. 5 equal portions. The other thing here is it says, what are the odds against spinning a blue, a yellow, and a green? I don't like the word and there because I'm not sure if they're separate sections that I can spin both a yellow and a green at the same time. So I have to assume that what they're saying is or here. What are the odds of spinning, what are the odds against spinning either a blue or a yellow or a green is how we're going to take this one. And the odds against, you can think of this a couple ways, but the odds against, the way I think of this, if I don't want to spin a blue or a yellow, that means I do want to spin an orange or a red, which are the other two colors. Well, again, it's success over failures, and if orange and red are success, though, because those are not blue, yellow, or green, there are 2 ways to succeed and 3 ways to fail, which gives me 2 to 3 odds. Again, this question's worded a little vague, so hopefully that interpretation is exactly what we need. Continuing on with probability, question 58. 8 balls are placed in an urn. Hey, we got an urn again. That's exciting. And we want the probability that the number that we draw, we're going to draw one number, and that we want to know the probability that it's not a 4. Well, we know the probability that it is a 4 is 1 out of 8, and we can do this a couple of ways. There are, of 8 numbers, there's 7 ways to succeed at not drawing a 4. So 7 out of 8, the answer is D. The other way you can think of it is 1 minus the probability that you do draw a 4. So you can do it that way too. It doesn't matter. You'll get 7 out of 8. 59, a coin is tossed and a die is rolled. What is the probability that the coin shows heads? Well, that's 1 out of 2. And multiply. The die shows an even number. Well, last time I checked, on a die, there are exactly half the numbers are even, so a half times a half gets me a 4th. Remember, and is often code word for multiplying. Okay, 60. Which of these pairs of events are dependent? Okay. So when we talk dependent versus independent events, we're talking about 2 or more events happening, and the question is, does one event depend on the other? So if we look at letter A, it says you spin a wheel, divide it into 7 equal parts, you get a 6 on the first spin, and then you spin again and get a 3. Well, spinning on that and getting that 3 was not at all affected by the fact that I spun a 6. So those events are not dependent. Letter B, you remove a white sock from the drawer without looking, and then you remove another white sock. Well, those events are dependent, because what happens is when you pull the first sock from the drawer, right, without looking, so you draw the first sock, there are now less socks, so it changes all your probabilities on the second sock. Now, probably to be fair, this question should be a little more clear, and it should say you don't replace the sock, but I think it's loosely implied, but still maybe not a great question. So those would be the dependent ones. Letter C, let's just so we have some clarity, let's look at letter C. It says you pull your teacher's name out of a box that holds 100 different names. Replace the name. Right there is why it's dependent. If you did not replace the name, you would have a dependent event. Letter D, you roll a die and then you roll it again. Die rolls. One does not depend on the other. They're totally independent. So B is the answer. Another good example of this is when we did problems where we would draw a card and not replace the card before drawing another one, and it changed our probabilities. Okay. Well, that is enough of probability, and we're going to get on to sequences and series. So 61 says write the first 4 terms of the sequence. Well, remember that when I want a term, all I have to do is plug in the term number for n. So if I want term 1, All I have to do is input a 1. A 1 equals 1. 3 times 1 plus 3. And let's see, that'll evaluate 2. Let's see, 3 times 1 plus 3. 3 plus 3 is 6. A2, I'm going to do the same thing, but I'm going to put a 2 in for n. So 2, 3 times 2 plus 3. So I'm going to get 6 plus 3 is 9 times 2 is 18. If I want the third term, I will plug in a 3. 3 times 3 plus 3. Dang, that's a lot of 3's. Okay, I'm going to get 27 plus 3 is 30 times 3 is 90. And you can use your calculator for this. The key thing, though, is that I'm taking each term I want and I'm putting the number. So if I want the 100th term, I'm going to put 100 in where n is. So let me grab the fourth term here. A 4 is 3 times 4 plus 3. See if I can still do this in my head. 12 plus 3 is 15 times 4 is 60. Whoops, I think I made a mistake back here. Okay, hang on. Back this up. Probably already hitting your head saying, gosh, Fox, you made a mistake. You're not going to catch it. Well, I did. Okay, so this is 9 plus 3. That's 12. 12 times 3 is 36. There we go. That looks better. So 6, 18, 36, and 60. All right, number 62 says, write a rule for the nth term of the arithmetic sequence. Okay, so arithmetic sequences all follow the same rule, and you should have this on your note card. The nth term is the first term plus n minus 1 times d, where d is the common difference. All arithmetic sequences are exactly the same except for where they start and what the difference is. And in this case, you can see I am adding 3. So if I fill back in around that, there's my rule. Now, you will probably have to choose an answer that is simplified. So simply distribute. I'm just showing it on the bottom because I'm running out of room here. And an equals negative 12 plus 3n minus 3. Again, that's me just distributing the 3. And then I'm going to finally combine my two like terms. And I'll end up with an equals negative 15 plus 3n. Or you can write it as 3n minus 15. And finally, number 63. This is probably one of the tougher problems of sequences in series. It says find the sum of the first 13 terms of the arithmetic series. Now, I think we might be missing some plus signs in between here. I think that's supposed to be a plus and that's supposed to be a plus. Negative 10 plus negative 6 plus negative 2 plus 2. I think you can see the difference is 4. Let's add a couple more here. I think the next term we'll add is 6 plus 10 plus 14. And to be perfectly honest with you, if I'm only asking for 13 terms, you might just want to do this by hand. You are probably more likely to be accurate. But we do have a formula. The sum of the first n terms of an arithmetic sequence is n a1 plus an over 2. Now let's fill this in for hours. We want the sum of the first 13 terms. And you'll notice the n shows up right away, so I'm going to put another 13 there. And then I need the first term, a1, well, a1's right there, negative 10, plus the last term, not sure what that is, but I know I'm going to divide by 2. So to get the last term, again, I could do it all by hand, but probably the quickest way is to use the rule. The rule for an arithmetic, which we just did in the last problem, says that the 13th term is the first term plus 13 minus 1 times d. And I think, let's see, that's 12 times 4 is 48 minus 10. I think I'm going to get a 38 there. And so if I do this piece of it on my graphing calculator, I will do negative 10 plus 38, enter, divided by 2, enter, times 13, enter. I will get a sum of 182. Good, that matches an answer that is here.